Hey guys, so in this section we're going to take a look at classes in Kotlin. So as you're aware, Kotlin allows you to program using the functional paradigm where everything is a function and functions are like first class citizens. You can also use the object-oriented paradigm where everything is an object. A class is essentially a blueprint of an object. So the way you define classes is using the keyword class. And let's do a class here called person, and that's about it. So this class is essentially you've created a template and it doesn't have anything. It doesn't have variables, it doesn't have any functions, so it doesn't do anything for you. It doesn't have a state, it's just a blank class. But you can go ahead and instantiate this class using the open and close brackets. So let's create a person object here. I don't have to define the type of the class because of type inference, and I can just go ahead and create an instance of this class, and that will work just fine. So let's go ahead and print this class and see what happens. If I just do a print ln and person, and let's go ahead and run that. So this just prints the toString representation of this class. Now let's create another object as well of the same class but a different instance. And if you print the toString method of that, or if you print that object, it's going to be a different object. So let's go ahead and run this. And so as you can see, it has the first one is some random value and the second one is a second random value. So these are like two objects of the same class. Now this class doesn't do anything. Let's make this class do something, do some work. So this class can have variables. So let's have like a variable called score, and we'll define it of type int and give it a value of 0. And we can, set this value from outside and get this value. So let's say I make this person dot score equal to 12, and then I can just go ahead and print this, right? And let's do this, and that works just fine. So it's a good thing to have your classes as immutable, so you can give it some values instead of putting in values in here. You can give it values through the constructor. I'll get to constructor in shortly, but generally when you define a class, you can define a constructor like this, and you will give it a value, let's say age of type int. And so essentially now if you see there are squiggly lines coming here, I can just give it an age of, let's say 20. The second person will have an age of 25, and then let's go ahead and print that. I'm gonna print the person one age. When you do this, so while instantiating the object, I assigned an age 20 to it, and we are just printing that value. Now, as I mentioned before, when I tried and print this object, it was essentially just printing the toString representation. I can override that. The way to do that is using the override keyword and use the fun keyword here, and I'm going to write toString. So the method signature remains the same. Returns a type string, and we're just going to do a return statement here. This is a person object. And if I try and print this, it is just going to print the toString representation. Now, where did this toString come from? So you see, every class that you define in Kotlin inherits from a superclass called any. You don't have to explicitly define any because it is given to you. So if you use the class keyword and define a class, you're going to be extending from the any superclass, and it has methods in it, equals hash code, and then there is a toString method. You're free to override this to give your own implementation, which is what we did here. Overrode the toString method and gave it a meaningful representation. You can do that with any class that you define. So that's how you create objects in your class. So now that we took a look at classes, how we can instantiate them, let's take a look at constructors. So whenever you create a class, let's delete all this code first, and let's talk about the primary constructor. So Kotlin provides two types of constructors. One is the primary constructor and one is the secondary constructor. So essentially, whenever you're creating a class, it is assigned a primary constructor by default, a no argument primary constructor. It is what you use to create an instance of that class. So if I just go ahead and create an instance of person, I am calling the primary constructor, which is this guy here. So you can define an explicit keyword there, constructor, but you don't have to, and unless you have an external, an annotation there. Now we're not going to go into annotations, but I just want you to understand that if you have an annotation like this, that's only it's only then you would need this to define the constructor keyword here. So let's delete this. So this is the primary constructor. Let's delete the explicit keyword as well. And then there is a secondary constructor. Although when you define a secondary constructor, you want to make sure that you delegate the call to the primary constructor. So the way you do that is using the this keyword. So when you do this, and let's have some value here, let's say of type int, and as you can see, there's a squiggly line which says that insert the this call. So this means it's calling the primary constructor here. And you can instantiate using the primary constructor, or you can instantiate using the secondary constructor. So in this case, let's do second person with a different, calling the secondary constructor like this. Now, usually we do not use the secondary constructor all that much. We would normally make use of the primary constructor, and as you can see that it does not take any code block, so you cannot execute any logic in it. If you want to do that, you can write an init block which starts with the init keyword. So you can write an init keyword and you can do some logic here. Let's say println, and execute some business logic, or put in some initialization code block here. Init block. Now if I run this code, so this block is always going to run, but it's going to run only once. So that is the initialization block. So let's go ahead and run this. So the init block is executed, and once I create the instance object, the init block is executed, and that will be executed any number of times I would create the instance of person, right? So let's create one more instance, and you'll see that the init block is executed for each of these instances. So essentially an init block is a block where you would just put in some initialization code. So to sum it up, Kotlin provides primary and secondary constructors. You can use either to instantiate the class. And if you want some block of code as an initialization code, you would have to put them inside the initialization block. Alright guys, now let's take a look at inheritance. Since we've seen what constructors are, let's remove the arguments that are given here. Let's remove this block as well. Before we look at inheritance, I just want to mention that whenever you assign any properties to your class, they are by default assigned getters and setter methods. So what do I mean by that? So let's say I have a variable here called greeting, and which is of type string, and it has a default value of hello. So if you don't do anything, by default, this is how it looks. It has a getter method, and that is equal to the field. Field is a keyword that you use, and then there is a set method as well, which refers to the setter method for the greeting, setting the greeting. So I'm going to do this, and here we're going to just assign the field to the value. So this is how it looks by default. So as you can see, there are squiggly lines here which tells you that you can remove these. These are redundant, so you don't have to do this. So if you don't do anything, and if you define a property, it's invisible. It's kind of there, but you don't see it. And likewise, if you put in some other value here, let's say you have an age property, and this is of type int, and I'm going to give it a value, let's say -1. So this has the same thing as well. So the ones that gets and set methods will correspond to this age property here. So they mean the same thing for both the properties. Now, the reason why I would want to override these or make use of these methods is when I want to override these methods into something else. So for example, in this greeting, if you don't do this, if these lines are not there, all you can do is just use your, let's create a person object here, and that'll be equal to person, and then let's do a person dot greeting is equal to hello, and print person.greeting. So if you do this, all you're doing here is you're just assigning this property, greeting property, to hello, and you're just printing that, and that works just fine. If I run this, and that was just fine. Now if I were to not override the getter and setter, that will be the same thing as well, and that's what it does. So if I want to override this greeting with something else, so I could just say plus a space and then a plus with another value called world. So I'm overriding the default set method to something else here. So if I run this, it is going to print hello world, because with the set method I have defined that, hey, take this value and add something to it. And likewise with the get method, it is the same thing. So if I want to, concatenate with something else, hello world, and give it something else as well. So I'll do hello world Kotlin. So all I'm doing here is when I set the value, I am setting the value to hello world. And when I get it, I get whatever is the result from the set and then add Kotlin to it. So it's printing that value. So if you don't really have to override it, but there are cases when you'd want a property to be custom made to something that you'd want to use, and that is when you would use your getter and setter methods. And this is the way to do it. So having said that, let's talk about inheritance and interfaces. So let's first delete this code. And this. So we have a person class here. Now in Kotlin, everything that you declare, every class that you declare is not exactly open. It's final. So if I try to extend or inherit from this class, I won't be able to do that. So let's create another class called man. And let's go ahead and try and inherit from person. And it gives me a squiggly line there. It tells me that the type is final, it cannot be inherited. And in order to inherit from the superclass, you have to make it open explicitly. And when you do this, you will be able to derive properties from the superclass. So if I have a function or a property here, so let's say I have age defined as an integer and with the value 0. And if I instantiate the man class, so let's create a man class with the man constructor. And if I try and print or access the value age, I will be able to do that. Sounds good. So inheritance, as the name suggests, as the name implies, it is inheritance. You're inheriting from the superclass. Kotlin supports only single inheritance, so you cannot have another class extending from, you cannot extend from multiple classes. You can do that using interfaces. So we'll look at interfaces a little later, but generally speaking, this is what inheritance is all about. And you can instantiate the person class here as well, which works just fine. Man.age. So this is of type person. The only difference is the first one that I did was of type explicitly of man, and now this is of type person. So far, and so all is good right now. Now explicitly, if you want to make a class, as a superclass for all the derived classes, you can use the abstract keyword here. The difference between open class and abstract class is you cannot instantiate an abstract class. It is just meant to be overridden. It's just meant to be extended by a different class altogether. So you cannot instantiate it like you were able to do that in an open class. So let's delete this and let's create an instance of the man class right there. Now in abstract class, you have the option of declaring methods, either abstract or leave them or give some default implementation. So let's have a method saying talk. We're going to make the man or the person talk, which is fine. So I have a default implementation here and talking. And also I have the option of making methods which are abstract. Now you have to make methods abstract with the abstract keyword. How do you do that? using the abstract keyword right in front of the method. And that works just fine. Now, because I have declared a method as abstract, all the subclasses would be forced to override that method. They have to give an implementation. They don't have to for the ones that already have a default implementation. However, since this method is abstract, what I'm saying is any class that extends the person class is supposed to give their own implementation for this method. So I have to override that method. So either you do that or you make the man class abstract. So I'm going to go ahead and override the walk method given my own implementation, and I am going to print man walking. Yeah. Now, Kotlin does not allow multiple inheritance, which means that if you want to extend from more than one class, you will be able to do that. If you want to do something like that, you'd have to use interfaces. So let's go ahead and create an interface here. So let's say a man is extending from person, and let's also make him an alien. So I'll have an interface alien, and it'll have a method fun do alien things. And that's about it. Let's also have another interface, cyborg, and we'll make him do some cyborgy things. So we are going to make a man who's a person, an alien, as well as a cyborg. So let's go ahead and implement our alien interface. Let's also implement our cyborg interface. And since these two methods are abstract, meaning they do not provide any implementation, we can go ahead and implement those members just like that and given our own implementation. So a man does cyborgy things, he does alien things as well, because he is identified as an alien as well as a cyborg. Interfaces also permit you to give default implementations for any of the methods that they have. So in this case, this is an abstract method, do alien things. If I provide a default implementation for this, you don't have to override, kind of like an abstract class. This is how it differs from in Java. So if you define an interface in Java, you won't be allowed to give any default implementation. However, in Kotlin, you can do that. Cool feature, something to take advantage of. So now you have multiple inheritance. You can provide default implementations for your interface implementation, and you can use these as any of these objects. So let's say I created a man object. If I want to typecast it as an alien, I can do that. So I can do alien just like that. And in this case, I'll only be able to access method inside an alien. So it only has do alien things like that. If I typecast it into something else like a cyborg, I'll be only able to do cyborg things. And that's pretty much it. Inheritance comes really handy when you think of your classes, when you think of things that your classes can do, and it's essentially a basic key principle of object-oriented programming. So whenever a problem is assigned to you, think in terms of object, think in terms of common qualities that your base class might have, which can be inherited. Think in terms of characteristics that your class can implement, which will fall into the category of interfaces, and have fun with it.